is called as Card in the Cloud, right? Which is an initiative taken by Criterion Networks, which is the company which I belong to help easy access to developer-friendly environments on the cloud, essentially, right? And the another part is the one more thing we have launched is basically what is called as a learning framework for COD. So as you guys all know, COD is pretty complicated. It has too many components involved with it, and sometimes if you are basically coming into this on day one, it's pretty confusing in terms of what is all these components doing, right? And what is it essentially achieving, right? And one of the biggest thing over there is to understand the different components, that is what does exhaust do, what does unos do, and all these things. So what we will do is, we'll just go through a couple of slides to basically understand what is the architecture we are doing and how are we different from COD in a box, right? And after that, each one of you will get a training pod essentially, where you can do hands-on exercise to basically understand all the different elements of COD, right? Yeah, go ahead. Sorry.
Is this the 2 o'clock session?
Yeah, this is the 2 o'clock session. So I have around 10 username passwords which I'll be handing out to you. You can actually share the environments if you want to, right? And again, so it's still in beta stage. We're going to be releasing it basically after 2 days. You can just try it out, and the pods will be active for till tonight. So you can actually, after this class as well, in case you are not able to complete all the steps, you are free to basically take it into your own environment and try it out, right? So with that being said, let me begin. So basically, just to give an overview, so we have Criterion Networks. Our main platform, what we actually have is something called as SD Cloud platform, which is basically a modeling platform where you can model different complex SD and NFV use cases. So COD is one such use case we have modeled and are providing as a service to ONF, right? And so we have 2 components here. One is from the learning side of the house, and another is basically the engineering sandboxes. So these are the following elements. So just to introduce myself, so I'm Pramod Venkatesh. So I basically am the director for cloud platform and operations from Criterion Networks. So I worked with COD starting from COD 1.0 onwards, basically in bringing up of COD in a reliable fashion, right? And we have significantly differed from how COD in a box is actually being present, right? I will come to the details on why we actually went through that model and why we did not follow some of the COD in a box principles as well, right? So my background is basically I was with Cisco for most of the times in the advanced services team. I worked with a service provider in India to build one of the largest Openstack cloud. Basically, it's called as Reliance Jio. And then I right now work in Criterion Networks. So that's essentially my coming both from a legacy and SDN specific. Okay. So before we begin, so let's understand by default what exactly we are talking about the COD architecture. So if you guys have gone through most of the COD basics, so how many of you guys have actually tried COD in a box till now? Okay, so you all guys have tried it out, right? And was it in a cloud lab environment? Yeah, basically, yeah. So for the guys who have not tried it out, I think you guys should basically try out to get a complete hands-on feel of what exactly COD is, and you will get more details on that. So essentially what we are trying to address, as we said, there are 3 kinds of COD architectures present. One is called as residential COD, another is called as mobile COD, another is the enterprise COD. And our focus and one of the main things what a lot of people are working to solve as of now is basically the residential COD. So it is basically to provide your central offices, which is basically as a data center, and provide, on your residential side, to provide a kind of a framework within which you can have on-demand services, right? So if you tried the card in a box architecture, one of the basic use case we try to do is the virtual service gateway. So what does virtual service gateway means is, today, in today's world, whenever you have basically a CP, that is whatever router you have, and whenever you are bringing up, connecting your laptop or any of these devices, all the DHCP request or whatever is currently being served from a specific server or DSLAMs kind of a servers which are sitting over here. Now the problem over there is you cannot apply dynamic policies. Say for example you want to have firewall or parental control or some of these elements. It's very difficult unless your device, endpoint device, actually supports those features, right? So with CORD, what happens essentially with virtual service gateway is you are moving away the intelligence from this specific point right into the fabric on top of CORD. What will that help is whenever you are bringing up any devices, this CPE device in your home can be a very dumb device, right? And all the policies are basically controlled by the virtual service gateway over here. So even your DHCP addresses which each of your devices would request would be forwarded all the way to your VSG, and that essentially provides you the IP address and provides you the internet connectivity point, right? So this is essentially one of the major use case we try to solve and try to understand the OR-CORD property, right? So why did we come up with a different architecture? So if you see in CORD in a box architecture, right, one of the biggest hindrance what we felt, and which you guys will also feel, is the size of the hardware required, right? So you need to just to bring it up is around 64 GB of, to have it at least working, a 64 GB server, right? Now if you are coming from the college community, or if you are coming from any industry, it is very hard to get access to that kind of environments, right? And that too essentially for just doing some development work or understanding work, it is very difficult to get. And even for us, we also felt the same thing. If we are supposed to provide this as a service to the community for all the CORD users, we could not get 64 GB servers as well, because it's very hard to get bare metal servers of that size. We even tried to do nested virtualization and all those kinds of things, but it doesn't work as expected. So what we did is we went to the drawing board back. We said, why don't we just rewrite some of the components what CORD in a box actually does. And that is essentially what we have done, which is called as CORD in a cloud. So how we bring up the CORD in a cloud, I'll just show you the architecture is, we do not have a single virtual machine or single thing. So we basically bring up 8 virtual machines, each doing its own work. So we have a VM which is doing only honors. We have a Openstack VMs, which is around 2 Openstack VMs. We have a compute node where actually the VSG VMs and everyone comes up. We have an Exhaust VM which is hosted for all the Exhaust services. And we have a load balancer basically which helps in scaling up and scaling down of your infrastructure. So in that way, we have actually reduced the overall requirement and can bring it up in a distributed fashion. Now once that is done, we could then spin this up in any of the clouds, right? So we could spin it up on an AWS servers. They basically take, so all of our VMs are all 4 GB VMs. So we have brought it up on AWS, we have brought it up on Google Cloud. We have our own cloud as well where we actually bring it. So that kind of eased the requirements, right? So it will help you to basically move it and get your own requirements in your own space, because you can now start using not only Cloud Lab but any other infrastructure, right? So that is essentially what we did, right? So basically what we have is we have a cloud-based solution development environment for CORD, and it's completely on demand. So for folks who have actually brought up CORD in a box, you need to run some scripts, go through it. If it breaks, you don't know where to actually go and troubleshoot it. So you would have faced all these issues. In our side, you don't need to do anything. I'll show a demo of that. So you can just log in, you can just say provision and it just comes up, right? And it takes much lesser time, so it comes up in another half an hour or so, right? So that is one thing. And accessing all the components of card are provisioned on separate virtual machines. So we don't have a single bare metal, it's completely spread out and you can actually go into that and scale each of these services independently. So right now, card in a box, it is essentially everything in one place. Say for example, you want to do it in a production environment and you want to have ONAS cluster. It's very hard to do that using card. Here, you can scale this independently. You can have ONAS cluster separately. You can add as many number of compute nodes you want. So if you want to do a high level scaling, today there is only one compute node, you can go and do 3 compute nodes. So all of this is specifically separated. And one of the important component what we have is, if you guys have been working with ONAS and XOS, they are still in developmental phases, right? So there is a lot of chance that today if it is showing ready, tomorrow it may not be in proper state, because some ONAS services would have failed, some RabbitMQ servers would have failed, some Nova services would have failed, and then when you try to play with the environment, what do? You will not get anything, and you have to go back into troubleshooting all these things. What we have done is we have built in the intelligence to basically do monitoring and self-healing. So up to the best of our efforts, whenever there is an issue happening on any one of these instances, it automatically tries to restart the service, tries to heal itself and get it up and running. So there are cases obviously with ONAS as such, so sometimes when it tries to get it up and running, it pretty much fails, it doesn't come up. But again, those are common cases where everyone is affected. But apart from that, we essentially are able to bring it up in a most reliable fashion. So what is our RGW solution has? So we have currently 7 virtual machines, as I mentioned, and all the services are accessible from SD Cloud. That means it's accessible through open internet, so there is no hidden stuff, and all of you will get basically root access into the environment itself. So you can destroy, recreate, bring it down, and do that. And we actually build an overlay common management network, which basically connects all the different virtual machines as if they are in one same management network, right? So that way it doesn't know that it's actually on different places. So we can have all these 7 VMs actually provisioned in different data centers as well, but our common overlay network actually provides a service such that it actually looks as if it's in one place, right? So yeah, so what do we have is basically, so we have the clients, right? So the clients, basically you guys who are trying to access all of these environments. So we have a service load balancer which is provisioned by default. What is the necessity for this is, we are ready to do scale up. That means today in your environments, maybe you are just using it for playing purpose. Tomorrow, let's assume that card is in a place where you want to see, I want to spawn up, let's say for handling 100 or 1000 clients, right? So in that case, you cannot scale up by just having one node of each. You would need multiple instances of this as a load balancing. Here, since we are already bringing up as a load balanced mode, you can very quickly add these specific components and multiply them so that you can provide you the scale which is required. And again, since it's distributed, you don't need one big box. You can have it as any environment wherever you would be, right? And so we have 4 components of the code. So one is the exhaust. So the exhaust main core is basically handling all the different containers associated to the exhaust services. And we have the ONAS controller. So this ONAS controller is essentially what is mapped to the latest release of the CORD. So if today we are supporting CORD 3.0, we are in process of writing for CORD 4.0, and right now we are using version 1.8.6. And then we have the Openstack Controller, which has all the different elements, such as Nova, Neutron, and all these elements as well. And the database, everything is present. And then we have the compute nodes, right? And these compute nodes are where, whenever you spawn a virtual service gateway, the VMs are actually coming up over here, right? Now, how do we make sure that we have a common management network is, we establish basically VXLAN tunnels across the network, right? So that means, while we have VMs separated out across, let's say using AWS infrastructure or any of the infrastructure, we have VXLAN tunnel which basically establishes a common management network across the system. So we can cross geographical boundaries, we can cross different cloud providers, so we don't need to be stuck with a specific use cases. So we are extremely scalable in that sense that even all of you guys will be able to do it. Right today, I'll be giving out 10 cord clusters. So totally I have 70 virtual machines which are there, right, for you guys. Like this, there are so many people using it. And it is extremely distributed across different data centers, different cloud providers, which you will not know. For all of you, it looks as if it's in one place. So that is essentially what we have done using this one. So it is extremely, yeah.
So the VTEP tunnels, you have them terminating, I understand, in OpenStack with OPS.
Yeah.
How are you doing that on the service load balancer?
Yeah, so what we have is, so there are two components to this. So there is a VXLAN tunnel which is being spread across these things.
Okay.
And then we have a VXLAN tunnel which is making all this. So for this, it will be VXLAN over VXLAN.
Okay.
So while, for example, it's just a interface,
Yeah.
which is given to the compute nodes.
Okay.
And OBS will create a VXLAN tunnel on top of it. Yeah. So it's like distributed stuff. So that is one. And apart from this, to provide a familiarity with respect to how it is actually deployed in actual environments, we have actually segregated what is called as a gateway router. So the gateway router is the one which basically does the service chain for you, right? So whenever your clients are there, they basically come in, they go into the VSG container, VSG virtual machine and into the container, and once they exit out, they basically come to the gateway router, which provides them the ability to access the internet. So that's how essentially it works in an actual SP environment. So we are trying to replicate that using a gateway router, which is another node specifically for this purpose. So as I said, so the OpenStack we are using is Kilo as per the latest COD 3.0. I think 4.0 they have moved on to Metaka, so that's the next upgrade we'll be doing. And SDN controller we are using ONAS 1.8.6 actually, and 4.0 will be on 1.10, the latest release they will be upgrading. So in an inherent sense, this is how it looks like, right? So so we have a subscriber client VM where you can actually spin up, emulate your actual users, right? So how you would actually have in a normal environment where you have a CPE equipment and you're connecting laptops, mobile phones and something like that, you can actually emulate your subscriber clients. And then we have an emulation OLT connection over here, which basically you can have your S tag and C tag to be added over here. And then we have the fabric connectivity, which basically takes the traffic all the way across into the compute node, which hosts the virtual service gateway. These are the controllers. And once this part is done, then this basically sends the traffic to the gateway router, and from the gateway router, it basically goes into the internet. So that means a client pinging 8.8.8 would essentially go all the way over here, come into the OpenStack compute node, and then go into the gateway router and into the actual internet. So this is essentially how we have provided.
Good question.
Yeah.
Is this just on paper or still you already deployed?
We already have it. So
You
today
deploy for the customer?
not for the customer as such. So what we are doing is basically for hands-on lab and
Lab trial.
Lab trials. Yeah. Because customers can also use this, right? So inherently, instead of having one full box, They essentially can have some of the controllers placed on the cloud and only have some of the elements over here. So those are some things.
Is your service provider or you provide a service for the service provider?
We provide the service.
So is there any real service provider deploy the service from you?
No. So still now, if you see COD, it is still not in that maturity state for even deploying.
Okay.
So what people are doing is they are even exploring right now and trying to understand the overall architecture of COD and seeing how we can deploy. So in some of the cases, if you are coming from a service provider who has a lot of infrastructure, COD in a box will be very easy to do. But a lot of people here, we don't have access to that infrastructure to have it ready-made and enabled, right? And one of the basic expectation is that you come from you need to be able to understand the bring up points, right? So if you're not from that background, for you troubleshooting a RabbitMQ failure is not, it defeats your entire purpose of bringing up the entire concept. Whereas in our case, it's like you say provisioning. It's our responsibility to get you a running COD cluster at any given point of time. So that is what we actually do. So I can give you a small demo basically. So it's a video as such, so that they can. So it's ready. This is our platform. So you can see there's a COD solution pod. You can just enter whatever you want to do. You can select different COD versions. So we actually will be supporting 4.0 going forward. Right? And then you can click on provision, and basically it comes into the ready state. So it takes around 20 to 30 minutes for it to come to ready state. And then you have specific access to access each one of the dashboards. So you have Openstack dashboard, you have ONOS dashboard, and then you have the XOS dashboard, which basically you can access.
Is this for training purpose or?
Training lab, development.
You provide the training class for?
Yeah, training class is also there. So, and then you have detailed infrastructure on how exactly it is designed. And each one of you can have SSH keys to access it so that it's completely secure environment. And one of the things which we also have is we're trying to test is basically to suspend and resume the component. What it helps is we do a memory back suspend of the device. So one of the most important component here is if you are keeping it running for a long time, you're going to be charged, right? And if you do a stop and if you bring it up again, then the problem. So then the problem comes is that when you bring it up, all the service will not be working. So the ability to basically take a memory backed image and restore all the service as if when you suspend and resume, it looks as if there is no restart happening, right? So how you would respond as a hibernate in your virtual machine. So it's quite a complex thing to do with 7 VMs and XOS containers and OpenStack and all those things, but we are trying to get that addressed and trying to make that happen, because once that is there, you are doing something, you suspend it, go back, come back, maybe on a weekday, resume it, and you're only charged for a specific period of time. And that will help you in terms of saving your cost, because you can have multiple environments which you can have. So that's what we are working to make that happen as well, right? So as we said, it's pretty flexible and customizable. So we can have different COD environments supported, right? And we can do multi-node, multi-controller with HA configurations and some of these elements as well. So if you start moving into production-grade deployments, you need to have multiple XOS controllers, you need to have multiple ONOS controllers, you need to have multiple Openstack controllers so that it is completely fault tolerant and highly available, right? So that is something which is very simple for us to basically do, because it's already pre-baked that we have the entire services to support them. Right? So currently we have COD 3.0 and again we are working on the 4.0 release, right? So it takes some time for us to basically take all of this and move in that direction. And so we have scripts for basically for scale and expansion and even for the testing as well. So we do a lot of testing even for COD community, because we actually keep it running for long periods of time. So we know if there are any issues which happens, and we continuously keep on seeing whether COD is actually stable for a longer duration of time. So we do see some issues such as ONAS has some memory issues and some of these things which we actually raise it back to the community to kind of, right? So for folks who are ONLab members, so we actually offer this as a community service to around 500 hours or so in this place. Basically, it's in Criteria Network/ONLab. You can go and request for it. You may or you may not get it because a lot of people may be using it and we may run out of hours very quickly. But in case, do try it out. But at least for this specific, as of today, so you guys will all have a playground to at least try it out. So we'll do that. So that is essentially the card in the cloud, which is basically the sandboxing in the cloud. Now the next thing what we wanted to do was to provide a learning lab construct, as I mentioned, that a lot of people need to know how exactly these components are called. So we are starting from ONAS Mininet, Openstack ONAS Mininet, and then finally Exos, Openstack ONAS and Mininet. So I mean the entire VSG kind of a thing. So that helps in terms of, so we have three components. One is called network management. We do called virtual networks, and finally the services frameworks to get you a deeper understanding of this. So today, the hands-on part of it, you all will be doing the last one, the called services framework, where you can bring up multiple VSG containers on the platform itself, right? So there is step-by-step instruction. So I'll be handing out the username credentials. So we'll do that once. Right? So essentially, so of course Larry and some of the folks have actually used it, and so basically we have the hands-on lab. So we are starting with right now what is called as a primer learning labs, which is essentially for a generic user community. We are working on launching something called as the developer track, where we'll be concentrating on onboarding example services, how to draw your own graphs, some of these elements which is more focused from a developer standpoint. And then we are basically moving towards having something called as a certification program. So similar to having your CCIE for part, right? Where you can actually go try out. We'll be giving you some examples, and you'll be actually be getting a certificate from ONF, which will give you the specific endpoints, right? So that is essential. And right now, all the labs are essentially available. So you can basically go and do an online subscription. So the pricing is essentially something like this. So we provide 24 hours usage time, right? You can spin up, if you are able to complete the lab multiple times, you can spin it up in these 24 hours. We currently charge $125 for it, for each one of them. And in that specific period of time, you don't need to start it right away. So you can do whenever you have the free. Whenever you pay for it, you will have for one complete month, out of which you will have 24 hours of lab time, which is there. So that is essentially what we currently have.
How many hours for that? 1 month?
So 1 month will be the overall subscription period,
Okay.
but you have 24 hours of active usage time, right? So if you split it up and if you let it running for 24 hours, then it will get expired. So
you can imagine you can suspend.
yeah, so that is the reason why we are working on making that suspend and resume happen, because you can have. Right now it's not there yet, because solving suspend and resume is it's a very hard task for us. So we are able to do it with OpenStack, but with called with the containers and some of the
But nowadays you will do it in 24 hours.
Yeah, it's more than enough for most of the purpose. Yeah, so it doesn't.
General, what is that?
It's around 4 or 5 hours it would take for you to basically go through it. So the reason why we do it is, a lot of times we have seen that when we give more time period, people are actually not utilizing it optimally. They just kind of leave it running and
Copy.
Yeah. So at least here we have a time-bound exercise so that people are forced to complete the labs, right? And so that is essentially what we have. Do try it out, and it's currently online. Again, so we have email support, monthly sessions, and if you want to have like a completion certificate, that also we need it. So what do we cover in each of these labs outline? For lab network management, as we said, it's all 4 hours each. So if you sit in a one setting, within 4 hours you should be able to complete all of that. Right? It's pretty much, you have a lot of text there, you can read about it. We start from the basics. We stay from understanding that you don't know anything about ONAS, SDN, something like that. So you have a basic philosophy about what exactly it is. See, for example, the lab network management, you're actually going to start with ONAS and Mininet. So you're going to bring up ONAS, you're going to say Mininet, make them talk, create some different topologies in Mininet, see OpenFlow, understand about OpenFlow and all these elements. Then once you are fine with that, then we come to the virtual networking, where the integration with Openstack and ONAS as the SDN controller which provides it. So how we are going to create with Openstack different VXLANs, how is the Horizon dashboard. So some part of Openstack is also included over here. And then we'll explore some part of how Neutron and ONAS basically integrates each other, right? So these are some things which are kind of hidden when you actually bring these things up, so you will basically get to know about it. And then the last part is basically the CORD services framework, where we will talk about CORD in general. We will do an understanding about XOS itself. We'll explore the XOS GUI, right? So one of the main thing is what is a slice, what is an image, what is a network resource. So we have to understand that both from a conceptual perspective and how it is actually mapped into the UI components. And then we will actually go into all these elements about where each component is present, and then we will understand from the CORD use case where we will create one virtual service gateway. We will verify the client communication. We will do a packet walkthrough, right? Where you will actually see the packet flowing from the client into the the compute node, into the VSG, into the Docker container. From there it comes out and do all this. So we'll get a complete full view of what exactly it is. Right?
Is it instructor?
It's not instructor.
It's self-started.
It's self-paced. So it's, and we have complete content on that. You can actually read through it. It's pretty much over there. Right? And then we'll bring up more number of clients. So as if more number of subscribers basically. So today's home 1, we'll have home 2, home 3 with different CiTC stack configuration and see how that basically will impact, right? So this is essentially what I wanted to cover from a high level perspective. So if you guys are okay, we can do the hands-on lab now.